Yes guys, shall we? Okay. So now, today we are going to study Spanning Tree Protocol, STP. So you can write the heading STP, Spanning Tree Protocol. Okay. Now in the previous class I told you STP or Spanning Tree Protocol is used to avoid the layer 2 loops. Suppose that if I take a diagram like this, suppose this is the diagram. We got three switches, S1, S2, S3. Three switches here. Okay. Now these switches are connected like this. Okay. Now this, let it be F0/1, let it be F0/2, this be F0/1, F0/2, F0/2 and F0/1. Okay, so this is the thing here. Okay, now before teaching you what is spanning tree and all, let me just tell you some terms here, spanning tree terminologies. Okay, so now the first term is called switch ID. Switch ID, or it is also called bridge ID. Okay, so now switch ID, or say you have studied about the router ID in OSPF, right? I taught you that, say, it is used to identify the routers. The same manner, switch ID is also used to identify the switches in a switch topology. Okay, now the switch ID or the bridge ID, it consists of two parts. The first part is called switch priority number. Switch priority number, and the second one is called switch MAC address. Switch priority number and switch MAC address. Switch priority number, it's a number or it's a value which ranges from 0 to 65,535. And the switch MAC address, of course, say this priority number is a 16-bit value, and the MAC address, you know, it's a 48-bit value. Okay. Now, so suppose this is the switch ID of S1, S2 and S3. Suppose this is the switch ID, say suppose 0, or yeah, or let it be 32,768. Then I told you this, the switch ID consists of two parts, switch priority number, which is a number, and then the MAC address. So this is the priority number of S1 and the MAC address. Suppose the MAC address is 0001 1234 1234. Okay, and this is the priority number, so 32768, or suppose 32769. Okay, or let it be 0 here. Okay, 0, then the MAC address is 0004 A4B3 C4D5, and this is S3. We can say the switch priority number 32769, and the MAC address is 00A A1B1 C2B2. Okay, so these are the respective switch IDs. Okay, any doubt here? Now the next term here. So now just let me copy it. We may need it later. Let it be here. Okay, now so S1, S2 and S3, these are the values with which we will identify the switches. Now the switches will identify each other with this value, which is called switch ID. Okay, now the next term is called a root switch. A root switch or root bridge.
You start the record?
Yes, of course I've started recording. No worries. Okay, so next term is called a root switch or root bridge. So in OSPF, I told you that, say, we'll select a leader router, which is called the DR. Similarly, here also we will select a leader switch, and the leader switch is called a root switch or root bridge. Now, the root switch or the root bridge, it's a switch with the least switch ID. The switch with least switch ID will become the root switch. So when I tell you the switch with the least switch ID, say, we will first check on to the priority number, because the switch ID itself consists of two values, the priority number and the MAC address. So first we will check on the priority number. So here in this figure, who is having the least priority number, guys?
Switch 2.
Switch 2 is having the least priority number, right? Say S1 is having the priority number 32,768, S2 is having the priority number 0, and S3 is having the priority number 32,769. So this switch, that means S2 is having the least priority number, so that means S2 will become the root switch here. Okay, now what if here instead of 0, what if the value is 32,768? Here also suppose it is 32,768. Then who will become the root switch? Switch 1 will become the root switch, because I told you, say, the root switch is the switch which is having the least switch ID. So when we talk about the switch ID, it consists of two parts, the priority number and the MAC address. So first we will check on the priority number. Priority number for S1, S2 and S3, the priority number is same. If the priority numbers are same, then we'll check on the, or we'll look on to the MAC address. Whoever is having the least MAC address will be considered as the root switch. So here, who is having the least MAC address here? Switch 1. Okay, because here it is 0001, it is 0004, and this is 0008. So S1 will become the root switch. Okay, so now consider S1 as the root switch now. So we have found out the root switch. Now the root switch is actually found out by sending something called BPDU. The switches will send something called BPDU. BPDU is called Bridge Protocol Data Unit. Bridge Protocol Data Unit. BPDU. Okay, so what happens is that these switches, the S1, S2 and S3, all these switches will start sending BPDUs. Okay, so they will start sending the BPDUs. So BPDUs are actually some internal switch messages. Okay, some messages internal to the switch. Now they will start sending the BPDUs. So at first everyone will start sending the BPDUs as if they are the root switch. Okay, so they will claim themselves as the root switch. So S1 will start sending like the BPDUs like this. So the BPDU will contain certain values. The first value is called a root switch ID. Who is the root switch? So for S1 will tell I am the root switch. So he'll be sending, say, its own ID as the root switch ID. Then it will send the sender switch ID. Who is sending it? Okay, the same thing happens with S2 also. S2 will also start sending the BPDUs. At that time, S2 will be keeping its own switch ID as the root switch ID. Then the sender switch ID will be its own ID. So initially everyone will be setting the root switch ID and the sender switch ID as its own ID. Then later, suppose that after some time, so suppose S2 has sent a BPDU. S2 has sent a BPDU with root switch ID as S2's ID and sender switch ID as also S2's ID. Later, S1 has sent the BPDU. Then S2 will understand, okay, we have a better candidate than me. We have a better candidate for the root switch than me. Then what he will do is that he will stop sending this BPDU, then he will forward the BPDU from the correct root switch, or whoever is having the least switch ID, he will forward that BPDU. Getting it? Okay, so usually I tell a non-technical example. Do I need to tell the non-technical example here? Sure. So here, suppose, say we got Ritik, we got Nishant, yes, and we got, suppose, Vijesh, we got, say, Satish, and we got Naresh. Okay, suppose 5 people are there. Now, at first, say, I came to the class, say, this is the first class. Okay, and I came to the class, then I told you, okay, I need a leader from you guys. Okay, then what you guys will tell is that Ritik will start telling everyone, hey guys, I am the eligible candidate to become the leader. Okay, so I am the eligible candidate to become the leader, so, and I am sending this message. Okay, now Nishant will also tell the same. I am the eligible candidate to become the leader, and say I am the center here. Same with Satish. Satish will also tell the same. Okay, so everyone will start telling that I am the eligible candidate to become the leader. Now, suppose Naresh is the best candidate. Okay, among you, everyone, Naresh is the best candidate. Now, Naresh will also tell the same. Hey guys, I am the best candidate. Now, Vijesh will receive this message. Now, Vijesh will compare his value and the Naresh's value. Then he will understand, okay, Naresh is the better person. Then he will forward the BPDU like this, or he will forward the message like this. Okay, so he will send it to Ritik like this. Hey Ritik, we have Naresh as the best candidate, and it is sent by me, Vijesh. Then Ritik will send it to Nishant. So we have a better candidate, or we have the best candidate, Naresh, and it is sent by Ritik. Now Satish will also send it. So, or Naresh will send it to Satish also. So everyone, the thing is that everyone here will come to know about Naresh. Yes. Okay. So that is the thing that happens here. Clear? So all the switch here, all the switch will come to know about the root switch here. So in this case, who is the root switch? S1 is the root switch. Clear? Now, so S1 is the root switch here, and everyone will come to know. Now all the rest of the root switch, all the switches are called non-root switches. The switches other than the root switch, those switches are called non-root switches. Okay. Now, so here we got the non-root switches. Who are the non-root switches? S2 and S3 are the non-root switches. Now let me tell you, we got S1 as the root switch, and S1 now will be sending the BPDUs. Now I told you the root switch will be sending the BPDUs. Now when the root switch is sending the BPDUs, it has to reach all the non-root switches. It has to reach all the non-root switches. Now it has to reach S2, it has to reach S3 also. Now between these switches, they have a connection, they have a link here, and the link has got something called coast, or the ports has got a value called coast between them. Okay, now the coast, so the next term is called port coast. Port coast. Port coast is the value associated with the ports here. Okay, is the value associated with the with the port. Now let me tell you here, you got some specific values. For Ethernet, the port coast is 100. For fast Ethernet, the port coast is 90. For gigabit Ethernet, the port coast is 4. For 10 gigabit Ethernet, the port coast is 2. So this is the short port coast method. And you got long port coast method, which maybe later you can read in the textbook. Okay, it's like some 20,000 to 2,200, those values and all. Okay, so for fast Ethernet, what is the port coast here? 19 is the port coast. Okay, now, so the coast value associated with this link will be 19. between that link there is a value associated with it, and the value is 19. Here also the value is 19. Here also the value is 19. Okay, now I told you the root switch will be sending the BPDUs to S2 and S3. Now a root switch can send the BPDU to S2 using two paths. Either it can go via this path or it can go via this path. Okay, so if it goes via the leftward path, the path cost will be 19 here. And if it goes via the rightward path, what will be the path cost? Yes, 19 plus 19 is the path cost. Okay, so the next term is called path cost. Path cost. The cost associated with the path. That's the path cost. Okay, and when you add the port cost, you will get the path cost. So here the path cost is 19 plus 19, which is 38. Okay, so now just give me a moment. So guys, please let me know if at all you are getting confused with the diagram and all. I can draw it one more time. Okay, now so here the path cost is 19 and here the path cost is 38. Okay, now so it is always better to send via the path which is having the least path cost. Okay, so now say suppose if we say Ritik wants to go to some place. So if he wants to go to a place, say he can go via one path through which it will be 19 kilometers. And if he goes via the second path, it will be 13 kilometers. So which path he'll choose? He'll choose the 19 kilometers path. Right. So always it is better to prefer the path with the least path cost. Okay. So again, let me just tell you the process here. So what we have done is, at first we have found out root switch. Okay, by either checking onto the priority or checking onto the MAC address. Okay, then the second thing is that we will find out something called find out the root port of all non-root switches. I haven't told you what is root port and all, just now I'll tell you. So now what happens is that S1, who is the root switch, need to send the BPDU to all the non-root switches, and say he need to send the BPDU to the non-root switch with the least path cost. So if you send via this path, you will have the least path cost of 90, and going via that path you will reach a port of the non-root switch, and that port of the non-root switch is called root port. That's called root port. So root port is the port, or it's the interface of a non-root switch through which it will receive the superior BPDU. So whatever the root switch is sending, that is called the superior BPDU. Okay, Ritik, do you want me to explain one more time? Clear? Okay, so the root port is a port, or it's an interface of the non-root switch, okay, through which it receives the superior BPDU with least path cost. Clear? Okay, now say here again, so this is the root port of S2. Okay, now so this is the root port of a non-root switch. Similarly, we'll have to find out the root port of S3 also. So we have all the non-root switches will have a single root switch. Sorry, root port. Okay, root port. So S2 is a non-root switch. It will have a root port which is F0/2. Similarly, S3 is a non-root switch. It will have it will also have a root port, a single root port. It can be either this interface or this interface. To calculate or to find out the root port, we will check the path. Going via this path, the superior BPDUs can be sent to F0/1 and the path cost will be 19. Or it can go via this path and the path cost will be 38. 19 plus 19 will give you 38. So which is the better path? This is the better path. 19 is the better path. Okay, so going via 19, you will reach S3's F0 slash 1. So S3's F0 slash 1 will be the root port of S3. Clear? Fine? Okay. So now let me tell you. So here we have found out the root port of both the non-root switches. For S2, F0 slash 2 is the root port, and for S3, F0 slash 1 is the root port. Clear? Now suppose you got another one more switch here. Say, let me mark it. So this is the root port, and this is also the root port. Now,
Hey, Bharat, when the root switch is sending BPDU packets, right? It will also send to the uplink port of that same switch.
it also send it to the
Uplink.
one. Okay. What happens is that, let me tell you. So of course at first they will start sending it. Okay, but later, they are receiving the superior BPDUs through that link. Then there is no need to send that back, right? Because he is getting the superior BPDUs through that link. Then why he need to send it back through that link? Okay. Now let me tell you the next thing. Suppose in this case, say, just give me a moment. Yes. Now let me add another switch here. S4. Now this S4 has got F0 slash 3 here, this F0 slash 1, this F0 slash 2, and this is F0 slash 3. Okay, now let me tell you here, to find out the, so suppose that S4 has got a priority of say 40,000 and some MAC address is also there. Okay, so S4 will not be the root switch. Okay, S1 will still be the root switch. Now S1 need to send the superior BPDUs to S4. It can send the superior BPDUs in two paths, either via the leftward path or via the rightward path. So going via the leftward path, what will be the path cost? 38 will be the path cost. Now going via the rightward path, what will be the path cost? 38 will be the path cost. So previously I told you that we will find out the root port of all the non-root switches, and the condition was we will check the least path cost. Okay, now the path cost has become a tie here. The path cost here has become same, tie. So 38 and 38. In this case we will check. So S4 is the one who needs to receive this BPDU, right? Now, so we'll check the sender switch ID. We'll then check the sender switch ID. If at all the priority, if at all the path cost is same, then the next condition is that we'll check the sender switch ID. So now S4, with respect to S4, the senders are S2 and S3. Then S2 has got a say switch ID like this, and S3 has got the switch ID like this, of which we will select the least sender switch ID. We'll consider the least sender switch ID. So S2 has got this switch ID and S3 has got this switch ID. So who is having the least switch ID? S2 is having the least switch ID because of this priority. So what happens is that, say, this path will be taken because S2 is having the least switch ID, sender switch ID, and that path will be taken, and going via that path you will reach F0 slash 1 of S4. So F0 slash 1 of S4 will be the root port of S4. Clear? So the next condition is that we'll check the least sender switch ID. We'll take the least sender switch ID. Okay. Now again, one more case. Let me just take another one more case here. Suppose that we have another switch S5. Okay, and this is F0/5 and this F0/10, this F0/10 and F0/5. Okay, now S5 has got a priority of 50,000. So again S1 will be the root switch. Now S1 has to send the superior BPDUs to S5. He can send via the upper path or he can send it via the lower path. Going via both the path, what will be the path cost? Same. 19 will be the path cost. At that case, what we will check? We will check the next value, which is least sender switch ID. So considering S5 here, who is the sender for both the path? S1 is the sender for both the path. So that also has become a tie. At that case, they will check on to the next value, which is called sender port ID. Sender port ID. Sender port ID. Sender port ID. Yes. So sender port ID, which is the sender here, S1 is the sender. So S1 has the port IDs F0/5 and 10. Now we'll take the least sender port ID. So among F0/5 and 10, who is the least sender port ID? F0/5 is the least sender port ID. Now you will take that path, and going by that path, you will reach F0/10 of S5. So F0/10 of S5 will be the root port of S5. Clear? Fine? Okay. So now here, so the next is we'll check the least sender port ID.
So who will block the second part, S1 or S5?
We haven't I didn't tell you about the blocking and all. We'll reach that. Okay. So now again, so let me just tell you. Okay, we have found out. So the root port of S2. This is the root port of S2. Okay, and this is the root port of S3. We have previously found it out, right? And this was the root port of S4. Okay, now the next root port was this one. So we have, what we have done is we have found out the root port of all the non-root switches. So how many non-root switches are there? 1, 2, 3, 4. 4 non-root switches are there. So we'll have 4 root ports. Okay, now the next thing is that we need to find out the designated port. So the next term is designated port. Okay, now designated port is found out for all LAN segment. A root port was for all the non-root switches. Now designated port was for all the LAN segment. Okay, and now what is a LAN segment? So the LAN segment refers to the link here. It refers to the link. So here this is one link, this is another link, this is another link, this is another link, this is next one, this is next one, and next one. So how many links we have? Say 1, 2, 3, 4, 5, 6, 7 links we have. So we have to find out 7 designated port. Okay, now let me just tell you about it. So the designated port will also be found out using least path cost. Using least path coast. Okay, so now suppose we are finding out the designated port for this one, this link. Okay, so S1 can send the BPDUs to S3, and then the path coast will be 19. Then S3 can send the superior BPDUs via its F0/3. Getting it? Can send it to this link. That's the intention. Okay, or he can send it via, or he can send it to S4. So the path coast will be, what will be the path coast? 38. Okay, and via S4's F0/2, it can send it to the BPDUs can be sent it to this link. So which will be the path taken considered? Say going via this path, you will only have path cost of 19. Going via this path, you will have the path cost of 38. So this path will be considered, right? Because of the least path cost. And going via that path, you will reach S3's F0/3. So S3's F0/3 will be the designated port here. This will be the designated port. Getting it? Okay, so this will be the designated port here. So this is the designated port. Okay, now having doubt? One more time. Sure. So here, so our intention, so previously our intention was the superior BPDUs need to reach all the non-root switches. Okay, here the superior BPDUs need to reach S2, here the superior BPDUs needs to reach S3, S4, S5. Now the superior BPDUs need to reach the LAN segment. Okay, that means the link. Okay, so you can send the superior BPDUs to this link via F0/3 or via F0/2. So now if you want to send it to F0/3, you can send it directly to S3, and from S3, S3 can forward the superior BPDUs to that link via its F0/3. Got it?
Yeah.
Then the path coast will be 19 here, because it has to send the BPDUs only through this link. Now it can send to F0/2 as well. It can send it through F0/2 as well. How it can send it? You can send it via this path, and S4 will receive it, and via S4's F0/2 you can send the superior BPDUs to this LAN segment or this link. Then you will go through two path, 19 again 19, so the path cost will be 38. Okay, now so of course with the path cost of 38 and 19, which one will it will take? 19 will take. So going via 19, it has reached S3, and then via S3's F0/3 it can send it to the LAN segment. So the least path cost is that one, so this will be the designated port. Got it?
Yeah.
Okay. Now what will be the designated port of this LAN segment? Okay, so again let me tell you, it can, to send the superior BPDUs to this LAN segment, S1 can send it to S2, and S2 can send directly to that LAN segment via its F0/3. Then the path cost will be 90, or else it needs to be sent to S3, then from S3 to S4, so the path cost then will become 38. Then say via S4's F0/1 it can be sent. Okay, so this, say going via this path the path cost is 38, and going via this path the path cost is 90. So you will consider, say F0 this path as the path cost, sorry, the this one, yes, the designated port. So this will be the designated port. Now let me tell you two easy methods to find it out. So always opposite to the root port you will always have a designated port. Okay, so this is one simple method to say go through. Okay, opposite to this root port, this is the root port, you will always have the designated port. Okay, so this will be the designated port here. Sorry. So this can be considered as a designated port. Okay, now this also can be considered as designated port. For this link, this also can be considered as a designated port, because say opposite to the root port you will have a designated port. Clear? Or you can go with one more method for the root switch. So S1 is the root switch. Yes or no? Yes, S1 is the root switch. Considering a root switch, all the interface of the root switch will be designated port. Okay, so you can write it down, say all the interfaces. So this will also be a designated, this will also be the designated, this will also be the designated. So all the interface of the root switch will be the designated port. Okay, so this is designated. This is also designated. This is also designated. Okay, so we have found out the designated port for all the LAN segments, right? Say how many LAN segments we have? Yes, 7. 1, 2. So we have found out 1, 2, 3, 4, 5, 6. 6 designated ports we have found out. So one more LAN segment is remaining, right? And we need to find out one more designated port. Shall we?
Yes.
Done, guys. In 1 minute it will be done. Okay, now so this is the LAN segment. So if you want to send the superior BPDUs to that LAN segment, you can send it via S2, and via S2's F0/1 you can send it to that LAN segment. Clear? Or you can send it to S3, and via S3's F0/2 you can send the superior BPDUs to that LAN segment. So going via this path, the path cost is 19. Going via this path also, the path cost is 19. So the path cost has become a tie, or the path cost has become same here, right? In this case, if the path cost becomes a tie, or if the path cost becomes same, then they will check on to the least sender switch ID. The least sender switch ID. Okay, now so here the least sender switch ID. So to this link, who is the sender?
S1. Sorry, S2 and
The immediate senders, S2 and S3. So S2 and S3 are the senders, and among S2 and S3, who is having the least switch ID? S2 is having the least switch ID. So that path will be taken. That means going via S2 will be taken. That means S2's F0/1 will be considered as the designated port. Okay, so we have found out the designated port for all the LAN segments also. And the last step is that make the root port and the designated port to the forwarding state, while the rest are moved to the blocking state. Make or move all the designated port and the root port to the forwarding state, while the rest are moved to the blocking state. Okay, that means I taught you about the switch interface states, right? Say I taught you we have some states here. What are the states? Blocking state, then listening state, learning state, then forwarding state, disable state, right? So now, yes or no, guys?
Yes.
Okay, so blocking state means you will not send any user defined frames. It is only in the forwarding state which forwards the user defined frames. Okay, so say the root port and the designated port. So this is the designated, this is the designated, this is the designated, root, designated. So all these ports will be moved to the forwarding state. That means these interfaces will be forwarding the superior BPDUs, as well as it will be forwarding the data from the user. But the rest of the interface, rest in the sense this interface, which is neither a designated nor a root. So it will be moved to the blocking state. So this is the blocking state, and this also is a blocking state, and this also is a blocking state. The interfaces which are neither designated nor root are moved into the blocking state. That means they will not forward the user defined frames. And what is the final result, guys? The final result is that, suppose if at all we have a computer, and we have a computer who is sending the broadcast here. If the broadcast is sent, then it will be sent to here, it will get blocked here. Okay, and it will be sent to here, and here it will get blocked. It will send to here, and here it will get blocked. It will send to here, and here it will get blocked. Here it will send to here, here it will get blocked. So finally, what we have done is we have blocked certain interfaces so that the loops will not happen. Clear? So this is the spanning tree. Any doubts? Yeah.
Enable it or by default it is?
Sorry?
We have to enable spanning tree or by
Yeah, by default it is already enabled, and by default this will be running, no worries. Okay, so by default these switches will be working. I mean the switches will be already automatically running the spanning tree. We don't have to worry about it.
even old or new?
Old or new also. Okay, so this is how it works, the spanning tree protocol. Anyone having doubts? No. Okay. So this is the spanning tree protocol. I suppose you understood, right? Okay. Now to customize the spanning tree. To customize the spanning tree. Suppose here I want to make this as the, say, sorry, this was 32768. Okay. Now I want to customize, say, this as the root switch. By default it is 32. So now let me tell you one more thing. By default all the Cisco switches have the priority 32,768. Okay, by default all the Cisco switches having the priority 32,768.
Any particular reason for that?
A particular reason, we don't have the particular reason. They might have like it's a 16-bit value, right? So the 2 raised to 16 is the maximum value it can go, and the value is 65,536. And see, they have just divided it by 2, and then they have got 32,768. Okay, it's just the middle value. That's it. Okay. Now let me tell you. So here you can customize it. Okay, now before customizing, shall I give you a topology so that you can find out the root port, the root switch first, then the root port, then the designated port, and find out what are the, say, block ports and all.
Yes, sir.
Okay, so now let me give a topology. Feeling bored?
No.
Okay. Just let me write everything, guys, then you can note it down. Okay. So these are the priority values: 32768 for S1, for S3 61440, for S2 this is 4096, for S4 it is 8192, and for S5 it is 0. These are the switch priority. Okay, and the respective interface are also given. Okay, now you can write and you can try to find out. And one more thing here, if you have 1 gigabit Ethernet and one fast Ethernet here, it'll be working in the speed of fast Ethernet only. Okay, then the port cost will be 90. Okay, yes, try to do it, guys. Take your time and do it. Unmute myself. What about online, guys? Done or still doing? What's your status? Lakshit, Naresh, Omar, Satish, Srikant, and Vijesh. Okay, guys, I hope you guys are doing it and you don't have any doubts. Take your time, guys, and if at all you have finished, you can take a 5 minutes break. Okay, we'll get back at 9 o'clock. Okay. So guys, what about online guys? Everyone done? Lakshit, Naresh, Omar, Satish, Srikant, Vijesh. Can't hear from you guys. What's your status? Guys, I hope you, at least someone can, I mean, you can you hear me guys?
Yeah, bro. Yeah.
So done? Awesome.
Yes.
Yeah.
Okay, then we'll discuss. Okay. So now, yes. So now, which is the root switch?
S5.
S5 is the root switch. Right. S5 is the root switch. Now, so we have found out the root switch S5. Okay. Now we'll find out the root port for all the other switches. For S4, S3, S2 and S1, we'll find out the root port. Okay. So for, say we'll go, Srikant, I'm with now Teams, some issue. Okay, Srikanta, no issues. Okay, maybe if at all you are busy with the work, no issues. Okay, so now we'll go with S4 first. Okay, so S4, which is the root port here for S4? Jig?
0 F0 oblique 2 or F0 oblique 1.
I was asking for the root port.
Okay.
Root port of S4. It is gig 1 here. It's gig 1 because from the root switch you can directly go to this S4, right? And the path cost here will be 4 only. Okay, now then again, say to go to, or you can go via this manner also. You can go via this manner, right? Then the path cost will be here 19 plus again 1938. Or you can go in this manner also. You can go via this path, right? Again it's gonna be higher, say 19 plus 19, 38 plus again 4 you need to add. Okay, or you can go via this manner also. That will be very high, right? So 19, 19, 4, 4, very high. So always you can choose the, say, least path cost path, which is this path. Directly you can send it and via gig 1 S4 will receive it. Similarly, now if you go for S2, which will be the root port here? Gig 2, gig 1 or gig 0?
Gig 2.
Gig 2. Everyone getting it, I hope? Okay. Now, so guys, if at all you have any doubts or if at all you want to discuss how you got gig 2, let me know. Okay. Want to discuss? No. Now, what about S1?
Via gig 2.
Via gig 2 only. Right. So, via
So just to reconfirm, between 2 gigs the port cost will be 4 and between a fast Ethernet and gigabit Ethernet it will be 19. Is that correct?
of course.
Yeah.
Okay. Because I told you, say between the fast internet and gig 1, say the bandwidth that they are gonna work is, or they are gonna say go with the 100 Mbps. Okay, so for 100 Mbps, then the path cost will be 90. Means for fast internet the path cost will be 90. Okay, so now I hope you got it. Now for S3, which one? I mean, sorry, for S3, which one? Which will be the root port?
F0
F0 / 4 will be the root port. Okay, because or else say, now let me ask you one more thing. What if it is gig 1 here? What if it is gig 1? Which will be the root port?
F0 the from S1.
Gig 1.
This one. Okay.
Sorry, gig 1.
Okay, because yes, say I told you instead of F0 / 1, if it is gig 1. Okay, then say here 4, 8, then 4, 12 and 16. Whereas if you go by this path, it will become 19. Okay, so yes, if it was gig 1, then this would have been the root port. As it is fast internet, this is the root port. Got it? Now we'll find, so here we have 4 non-root switches. We have found out 4 root port. Now we'll have to find out the designated port for all the LAN segments. So how many LAN segments are there? 1, 2, 3, 4, 5, 6, 7, 8. Okay, now so between this, say this one, S5 and S4, this will be the root designated port, because I told you to the opposite. You can go with 2 ways. To the opposite of this root port, you will have the designated port, or all the interface of the root switch will be the designated port. Like that also you can go. Okay, now again this will be the designated for the, say, this one, S3 and S5, that will be the designated. Clear?
Yeah.
Okay, now this will be the designated here.
Right.
Yes, and this will be the designated here. Okay, so we have found out the designated for, say, some links. Now for the next links, so for this link, what will be the designated port?
S4, F0.
S4 F0/1 will be the designated port. Now for this link, which will be the designated port?
S4, F0.
S4 F0/2 will be the designated port. Now for this link, which will be the designated port?
S2, P1.
S2 gig 1 will be the designated port. Now for this link, which will be the designated port?
S3, F/1.
Are you sure?
For this one, no, okay,
S1 gig 0.
S1 gig 0. Okay, this will be the designated port. Okay, so the figure that I gave you is easy. Okay, so how many designated ports we have found? 1, 2, 3, 4, 5, 6, 7, 8. I suppose everything's done, right? And now we'll block the unnecessary port. So this is an unnecessary port, we'll block it. There's another unnecessary port, we'll block it. There's another unnecessary port, we'll block it. There's another unnecessary port, we'll block it. And anything else remains? No. Okay, and then if you check, you will have no path for loop here. You go here, block, it will go here, block, it will go here, block, it will go here, block. So this is how they will find out the, say, or this is how the spanning tree works. Okay, now a very simple one, a very, very, very simple one, and that we will be doing it in the, say, packet trace as well. Okay, so now here, suppose this one, we got 3 switches. S1, S2, S3. F0/1, F0/2, F0/1, F0/2, F0/1, F0/2. This having the priority 0, this having the priority 32,768, and this having the priority 61,440. Can you find it out fast? Faster. Yes. Okay, look, no worries. Okay, you can drop, no issues.
S1 is a switch port.
S1 is the root switch, is the
Root switch. Root switch.
which one?
S1 is a root switch.
Yeah, S1 is the root switch. Yes, very good.
And F0/1 and F0/1 both are in designated.
Yes, guys, just a small thing here. Okay, let it be F0/10 here, because, okay, yes, let it be F0/10. And
Yeah,
let
both
it be
are
F0.
designated port.
Just a few changes here, F0/10 and F0/20 here. Okay.
Done.
Done. So now we'll say discuss the answers. Okay, so this one, right, just give me a minute. So both these will be the designated here.
Yeah.
Yes. Okay.
Can I tell?
Yeah, of course you can tell about the root port now.
In it's S2 F0/2 is the root port.
Okay.
In S3 F0/20 is the root port.
Okay.
And in between S2 and S3 F0/1 will be the designated port because of low switch port number,
Okay.
and F0/2 will be in block condition.
Yes, that's good. So this is the diagram. Okay, and we will do it in the packet tracer also. Okay, so just give me a minute while I take the packet tracer. And let me take switches like this, say suppose this is S1. Okay, suppose this is S2. And this is S3. So now guys, I'm just gonna change something here. Let this be here, instead of 0, let this be 4096. Still the answer will be the same. Okay, let this be 4096. Okay, then the answer will still
Still the same.
yeah, it will still be the same. So now let me connect it. Say F0/1 to 2, 1 to 2, and 10 to 20. So 1 to 2 again, 1 to 2, and 10 to 20. 10 to 20. Okay, now just give me one more minute. Okay, so now you can see the ports. Okay, but say I told you by default the priority will be 32,768 for everyone. Okay, and it is aligned in such a way that it will be like the root port will be selected based on the MAC address and all. Okay, and I presume that this might be the, say S2 might be the root switch. Okay, now to change or to customize, let me just configure these values here. Okay, so let me configure 4096, let me configure 32768, we don't need to configure. Okay, and 61440 will configure. So let me show it to you. By default it is 32768 for everyone, and so here we'll go to the packet tracer, we'll go to S2, and we'll execute the command like this: show spanning FN tree. Show spanning FN tree. You can see, say the spanning tree enable protocol
716.
IEEE. Okay, yes, and you can see root ID, the priority is 32769 here. Let me tell you how you got 32769. Okay, the priority is actually 32768 only, and you have a value called system ID extension, which is this value. Here you can see 0001. So this one will be added here, and then you will get the priority as 32769. So the priority will be 32768 only, but when you add the system ID extension, then the value will become 32769.
It will also increase when we make.
Sir, if I change the VLAN number, then the system ID will be changed with the VLAN number.
Yes. Okay. Now,
That number is added, right?
sorry.
That number will be added with the
That number.
768.
Yes. Okay. Now, so if you have, say, nothing guys, he just told that if at all we have a different value here, that different value get added here. Instead of the 1 here, they will add, if it's a 10, then they will add 10 here. Then the priority will become 32778. Okay. Now, so now you can see S2 is the root switch. So now let me just, here this is the switch to S2. Okay, S2 is the root switch. You can see this bridge is the root here. Okay, and say because of the MAC address, it has become the, say, root switch. Now let me configure the priorities for S1. So I'll go to S1 here, and first let me change the host names so that you will not get confused. Host name is S1. Okay, now let me go to S2 as well. Having doubt, Ratik? Okay, so host name is S2. Now the next one here, the host name is S3. Okay, now that we have changed the host name, now let us say change the priority. So here the priority is 4096. So by default the priority is 32768. Let me show it to you here. Do show span or show spanning FN tree. Do show spanning FN tree. You can see the root ID is 32769. The root switch priority is 32769, and the bridge ID is its own priority. This switch's own priority is also 32769, because this value got added. 32768 plus this value will give you 32769. Now let me configure the priority as 4096. For that, we'll go to the config mode and we'll mention the command like this: spanning-tree VLAN 1. Okay, we'll talk about VLANs later. Now we'll give the priority as 4096. Okay, so now the priority has changed to 4096. Okay, now if you take the command do show span, you can see the root switch has changed. So the root switch ID is priority is 4097. Previously the root switch ID was something like this, 32,769. At that time the root switch was S2. Now who is the root switch? Now the root switch is S1 here, because it has got the lowest priority, which is 4096. Clear? Now, so 4096 plus this one will give you 4097, and you can read this bridge is the root. Okay. Now you can see later, you can see, say all the interfaces will be going into the forwarding state. So both are designated. F0/1 and F0/10 both are designated. Okay, so here you can see both F0/1 and 10 are designated. Okay, now let me change this priority as well. Here for S3 the priority is, so we'll change the priority like this: spanning-tree VLAN 1 priority. What is the priority? 61440. Okay, if I configure 61440, so again, okay, so now you have already seen that this is the designated. Both these are the designated. Okay, now when you go here, you can see for S2 you can see F0/2 will be the root and F0/1 will be the designated. Okay, so now F0/2 will be the root and 1 will be designated. So do show span, or do show spanning-tree. F0/2 is the root and F0/1 is designated. Both are in the forwarding state. Clear? Now considering S3, F0/20 will be the designated, the root, and F0/2 will be blocked. Okay, so now again we'll go to do show span. You can see, say F0/2 is blocked and F0/20 is in forwarding state, and that is the root port. Any doubt? Okay, so this is how you will customize the root switch. Okay, to customize the root switch, what you're gonna do is you're gonna say change the priority. Okay, yes?
So go to the S3 switch.
Yes. S3, yes?
Yes. Give the command show spanning tree. Oh, it is out there, already there.
Yeah, it's already there. It's the same.
So now my role is thing is that there is small confusion. Status of the port is blocked. Okay. The role is alternate.
That is because of something else, which I'll teach you later.
Okay, sir.
Okay. Now you only have three things here: a root port, designated port, and the blocked port.
Okay.
Okay. Yes. Okay. Yeah. Now we'll come to so this is how you will change the root switch. Okay. By changing the priority, you can change the root switch. Now, how to change the root port? Again, to customize the root port, you will change the coast. You can change the coast. By default, you know the coast is 19 here. Everywhere the coast is 19. Again, you can customize the coast. Right? Say suppose if I customize the coast like this here, suppose the path coast here it is 19, here it is 19, here it is 19. In all the cases it is 19. Now what I'm going to do is, here it is a block state as well. Now if at all I change the coast here to suppose this coast to 40, the coast is now changed to 40. Now what happens is that, say going via this path, here it is 19, here also it is 19. So previously this was the root port here. Okay, now what happens is that this will become the root port. Okay, and this will be the designated port, and this will become the block port. Shall we check? Okay, so to change the course, what I'm going to do is I'm going to go to S2 and I'm going to go to this F0/2 of S2 here, and then I'm going to change that value. Okay, so now let me go. So S2, yes, say suppose the command is spanning tree. Sorry, we'll go to interface F0/2. Okay, I told you that we are going to change the cost of this F0/2 to 40. Okay, so I'll go to that F0/2. So interface FA0/2. Then we'll mention the command spanning tree VLAN 1 cost 40. So this is how you will change the cost. Clear? Then what happens is that, say after, so here you can see this was the blocked. Okay, now it will become forward, and then after later this will become blocked. Okay, so now let's see that. Yes, now you can see it. Okay, so this has become the blocked and this has become to a forwarding state. Okay, so now if you take a look at here, so because say going where this path, this value is 38, and going where this path, the path is 40, and so this path, the least path course will be taken. So the F0/1 will be the root port and F0/2 will be the block port. So now if you check, do show span. Okay, so this F0/2 will be the block port and F0/2 will be F1 will be the root port. Clear? Okay. So this is how the spanning tree, or this is how you will customize the spanning tree. Okay. Yes. Now. Okay. Now that we'll study some more things here. Okay. Now the types of spanning tree. Types of spanning tree. Types of STP. Okay. So types of STP. Say the first is CST, common spanning tree. That's what you are studying now. It's called common spanning tree. Okay. The second one, PVST, per VLAN spanning tree. And the third one, RSTP, a rapid spanning tree. And the fourth one, MST, multiple spanning tree. So these are the types of STP. Now, so about the CST, PVST and MST, we'll talk about it later. I'll teach you once we have completed a portion called VLAN. So you can note down in the backside of your notebook CST, PVST and MST. CST, PVST and MST. You can note down in the backside of your notebook. Just give me a minute. So now guys, see these three we'll talk about it later. CST, PVST and MST we'll talk about it later. Now we'll study about RSTP. Okay, so you can write the heading RSTP. RSTP. The name is Rapid Spanning Tree Protocol. Rapid Spanning Tree Protocol. Okay. Now rapid span. So here, say what happened earlier was, so here I changed the priority. right? Say I change the priority here, I've changed the priority to 40. Now what happens is that it will take some time for this interface to come up, right? It will take some time for this interface to come up. Or if at all I negate the command, if at all I go here and negate the command, interface fast internet 0/2 and negate the previous command like this. Yes. Okay. So again it will take some time for this interface to come up. Right. It takes, because the spanning tree runs certain timers. Okay. STP has got certain timers, and based on the timers only they will be working. Okay. So it is much more slow here. So RSTP or rapid spanning tree protocol is much more rapid. It is rapid. Now, so RSTP has got some states here, or say suppose, let me just tell you about those. The first state is discarding state. Discarding, learning, and forwarding. These are the states here. Discarding, learning, and forwarding. So you do not have the blocking state and listening state. Instead of the blocking and the listening, you have discarding. Okay. Now, so here so this, or it will make this rapid spanning tree much more faster. Now one more thing here. So RSTP has got some port roles. The port roles, root port are there. Root port, designated port. I've already taught you that. Now the third one, it is the alternate port. It's the alternate port. Now fourth one, it's called the backup port. Yes. So root port, designated port, alternate port, and backup port. These are the RSTP port roles. RSTP port roles. Okay with the root port and the designated port?
Yeah.
Okay. Now the alternate port, it says it is the alternate one for the root port. If at all the root port goes down, or if at all say some values of the root port changes, this alternate port will be made up. Immediately it will be made up. Now the backup port, it is the backup, or it is the alternate for the designated port. If at all the designated port goes down, the backup port will be selected immediately. Okay. Now previously, say somebody has pointed out, even if you check this S3 also, show span, you can see the alternate port. This is the alternate port, but say they will find out the alternate port, but they will not use it. Okay, even if say this, you have an alternate port, they will not be considered faster. That will not be made up faster because of the timers and all. Right. So if at all, again, if you change it to rapid spanning tree, say spanning-tree mode rapid-pvst is the command to enable the rapid or RSTP. Okay, so if you enable this command, spanning-tree mode rapid-pvst, if you enable this command, again spanning-tree mode, not in config mode, in the global config mode. Okay, so spanning-tree mode rapid-pvst, and again spanning-tree mode rapid-pvst. Okay, now that if I change the, say now again I'll go to this interface.
You have to configure it in all the switches.
Yes, but again if you don't configure in all the switches also, what happens is that it has backward compatibility as well. Okay, so now see here spanning-tree, sorry, not this one, here if I give this as the coast. Okay, so here you can see here, now this is the block port, this is the blocked, and this is the root. Yeah, forward root. Okay, now if I change the priority, okay, it will not take much time here. it will only take 15 seconds for that to come up. Okay, so here it will not take much time, and when you check it, do show span. Okay, now so not in
You
S2.
are already in S2.
Okay, here in S3. Okay, now f0/2 has not come up. Just give me a minute, guys. Okay, so again what happened, let me again say here, let me take no. You can see the immediate change here. Okay, did I give the yes or no? Just give me a moment. No spanning tree course 40. Here I given spanning FN tree, we done 1 course 40. Just a moment. In which interface I am there? f0/2 only, right? f0/2. Just give me a moment, guys. Here,
It's only a packet table.
yeah, that's also one thing. So now interface, just give me, do show span. Let me check the coast is 19 here. For both the coast is 19 and coast is 19, so it is working well and good. Okay, now if I change, say spanning FN tree VLAN 1 or spanning FN tree coast, what's the coast? 40. Okay, VLAN 1 coast 40. Okay, it ought to change, guys, but unfortunately I have no idea why it's not changing.
Reload it.
Yeah, reloading it won't. Just give me a minute. We shouldn't be reloading it, but still. Okay, now it has come turned up. Okay, so actually we shouldn't reload it because, okay, again just let me negate it. S2, if I give it interface f0/2, no spanning FN tree VLAN 1 40 coast 40. Okay, now you can see this has immediately, it has come up now. Sorry, this will come up. Okay, this has come up and this has gone blocked. Okay, now if I change this one, again this will immediately come up. Okay, that part, something is the problem, something they have the problem. Really don't know whether it might be the issue with the packet tracer, maybe. Okay, no, this has become down. Okay, nope. So course 40 means this has to come up here. Okay, which is not coming, maybe the issue with the packet tracer. Okay, I'll confirm it and let you know. Okay, so this is, say, the rapid spanning tree protocol. Okay, if at all something goes down, say immediately another will come up, and so then it is much more faster than the STP. Okay, yes. Now about the next thing, we'll go with the next topic called VLAN now. Okay, so you can write the heading VLAN. Okay, now, so yes, let me take paint as well. Suppose you got a switch here. You got a switch and multiple computers. Suppose f0/1, f0/2, f0/3, f0/4, f0 slash 5 and f0 slash 6. Okay, now if you send something, I've told you that it will be sent, if it's a broadcast, it will be sent to all the interfaces here. Yes. Okay, say in excluding this source interface, and this is called flooding. Yes or no?
Yes.
Okay, so if at all you send a broadcast, then it will be sent to all the interfaces excluding the source interface, because everyone here belongs to the same broadcast domain. Clear? Now what I'm gonna do is, so now everyone here belongs to the same broadcast domain, and this broadcast domain in which everyone participates is called VLAN 1, okay, or the LAN 1. Okay, LAN, of course you know, local area network, LAN 1. Okay, or we'll call it VLAN 1 also, virtual LAN 1. Now what I'm going to do is, say everyone, I told you it belongs to a LAN which is VLAN 1 here. Now what I'm going to do is, I'm going to create another LAN. I'm going to create another LAN here. So this is one LAN. Okay, this is one LAN here, and what I'm going to do is, I'm going to create another LAN. If you want another LAN, what you need to do, you need to have another switch, and you need to connect another computers, right? So here, but I'm not going to take another switch, I'm not going to take another computers, but I'm going to split this LAN into another small LAN. Okay, so again let me tell you what I'm going to do is, say by default you had a LAN here, and that's called VLAN 1. Okay, now you're gonna create another LAN, not physically but logically you're gonna create it. Logically you're gonna create, or logically you're gonna group it. Let me tell you an example here, the non-technical example. Suppose we got some students here. Okay, suppose by the starting of the class everyone is considered to be equal, right? By starting of the class, say no one know about the CCNA, everyone came to know about CCNA. Okay, now suppose after some class 4 people got absent, 4 or 5 people got absent. Okay, they were continuously absent for 2 weeks. Now these 4 people are continuously present, no issues. Then what happens, a kind of groupism has occurred, right? So even if I teach the class also, I'll have to say teach these 5 people separately and these 4 people separately. But whoever is looking from the outside, they will think it's a single class, right? So what we have done, we have separated, or we have made a groupism in this, say, classroom. Okay, we have made a groupism in the classroom, but that is not physically, that is logically. Only the people sitting inside this classroom knows about this grouping. But some other guys, when he sees from the outside, they will think that we only have a single class here. Now maybe I'll be taking routing for these guys, and I'll be taking switching for these guys. So within the classroom itself, or within the LAN, local area network itself, we got multiple divisions, or we got multiple separations, and each separation is called a VLAN. It's called a VLAN, or it's called a virtual LAN, because say everyone is connected to the switch, and if at all it's connected to a switch, it is supposed to be connected to the same LAN, but virtually you have split it into different LANs. Clear? Okay, and you got many advantages of the VLANs. Many advantages in the sense that you can group these machines logically. Suppose, okay, say this is the switch. Okay, here f0/1, f0/2, f0/3, f0/4, like that it's going. And in f0/24 you got 1%. f0/1 can be connected to one sales team, and f0/24 can be connected to another sales team, and the rest can be connected to the marketing team. and then you can group it logically. F0/1 and 24, it is of the sales team. You can group it logically. Okay, and the rest of the interfaces you can group it logically as the marketing team. So the advantage is that you can group these machines logically. Clear? Okay, so this is the advantage. And again, a traffic efficiency, or say suppose if at all, say this guy is in sales. Okay, if the problem, and this guy is also in sales. If we have not created the VLANs, or if we have not grouped them together, let me tell you what happens. If at all a broadcast is sent from this machine, then it will be sent to, yes, this machine, all the machines, if the VLAN is not set or the group is not set. Clear? Unnecessarily we will be sending the traffic to some other machines as well. Okay, so the traffic efficiency or the management, traffic management also, so that also is, say it's I mean with the creation of VLANs, that also is good. Clear? Okay, so now wherever you go, you will have the VLAN concept implemented in that network. Okay, now let me just tell you, let me show it to you. Suppose I have some machines here. Okay, I have some machines, and let me connect these machines here. Suppose this is, say, let me connect also. This is F0/1, 2, 3, 4, 5, 6. Okay, now let me just connect it here quickly and give an IP. So suppose this IP here is 10.0.0.1 and this .2, 3, 4, 5 and 6. Okay, so suppose let me give it faster here. So this is 10.0.0.1. okay, suppose it's /8 itself, and this is 10.0.0.2 /8 itself. Okay, now this is 10.0.0.3 and this 10.0.0.4. Next is 10.0.0.5. and this 10.0.0.6. Now let me take the switch here. Let me take the switch and execute another command here. Show VLAN brief. Show VLAN brief. You can see the default, say you got some default VLANs. The VLAN 1 is a default VLAN. I told you VLAN 1 is a default VLAN, and by default all the interfaces, all the machines will be under the VLAN 1. So here you can see VLAN 1 is a default, and you can see F0/1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Everything here comes under VLAN 1. And you got some other VLANs also, 1002, 1003, 1004, 1005, which are the default VLANs for another, say, network standards. So VLAN 1 is the default VLAN for Ethernet network standard. Okay, so here you can see all the interfaces are participating in the VLAN 1. Okay, and so what happens is that if at all this machine is sending a broadcast, it will be sent to all the interfaces because everyone is participating in the same VLAN or same broadcast domain. Shall I show it to you? Okay, so again we'll go to the switch, we'll ping to everyone, ping 10.0.0.2, you're getting the reply, and ping 10.0.0.3, you're getting the reply, and ping say 10.0.0.4 also you're getting the reply. Am I right? Okay, and 10.0.0.5 also you're getting the reply. Okay, and 10.0.0.6 also you're getting the reply. Okay.
So can I give the command ping 255 255 255 255?
You can give, but it won't work. Okay, ping 255.255.255. Okay, ping request could not find the host, so you have to ping it, say to that exact host here. Okay, because this is the broadcast address and you can't ping to the broadcast address now. Okay, now
But we can ping the gateway, right? 10.0.
gateway and all you can ping it, but this is the broadcast address to which you can't ping. Okay, yes. Now let me tell you about it. So here, yeah, now coming back, so everywhere you can see not this broadcast, except when you ping individual machines you can see, say, the reply here, right? You already seen the reply, because everyone belongs to a same broadcast domain. Now what I'm going to do is I'm going to make them participate in different broadcast domain. I'm going to create another broadcast domain, or I'm going to create another VLAN 10, and I'm going to make this F0/4, 5 and 6 participate in this VLAN 10. Shall we do it?
Yes.
Okay, so what I'm going to do is I'll go to the switch and I'll mention the command like this, VLAN 10. Okay, I'll go to config mode and mention VLAN 10. Then suppose if you want you can give the name, suppose sales department or marketing department, whatever. Okay, then we will exit and do show VLAN brief. You can see a sales VLAN has been created, but still you do not have any interface in the sales VLAN. It's nil. So now to go to or to make these interfaces participate, to make F0/5, 4, 5, 6 participate in VLAN 10, what you need to do is that you will need to go to the switch interfaces. That means interface FA0/4 you need, or FA0/5, FA0/6. You can go into these interfaces, or you can go into these interfaces together. You can go by mentioning a range command, interface range fast Ethernet 0/4-6. That means you are into that range of interfaces, you are into that group of interfaces together. Okay, then you will mention the command like the switch port mode access, switch port mode access, which I'll tell you later, maybe tomorrow. And then the command is switch port access VLAN 10. These are the commands. Okay, two commands. We'll go to that range of interface, we'll mention switch port mode access, and then we'll mention the switch port access VLAN 10. Okay, now when you take do show VLAN brief, you can see F0/4, 5 and 6, they have been added to VLAN 10 here. Clear? Any doubt? Now if you go and ping to, say if you ping to these machines, now if you ping from this machine to say 10.0.0.2, 3, you will get the reply, but 4, 5 and 6 you will not get the reply, because whatever you send will not be sent to this one, because it's in a different broadcast domain. Clear? Shall we check? Okay, so again we'll go to this computer, we'll take the command prompt, sorry, yeah, you're getting 10.0.0.3, okay, and 10.0.0.2 also you will get, but 10.0.0.1 you will not get, sorry, 10.0.0.4 you will not get, because it's in a different broadcast domain. Clear? Everyone online, guys?
Yes, sir.
Okay, anybody else having doubt or anything? Yes? No? Okay, then we'll give you a homework. Okay, so we'll give you a homework. What you need to do is that you need to take a switch. Okay, so let me give. And you can create 4 VLANs. Suppose F0/1, F0/2. Okay, you need to give the IP range 10.0.0.0/24 range. Okay, and both should be in VLAN 100. Okay, and here another one, F0/3 and F0/4. Let it be of the range 20.0.0.0/24. For each VLAN we'll be giving different IP ranges. Okay, and this is, suppose it's VLAN 200, and this is another VLAN, say F0/5 and F0/6. Suppose it's in 30.0.0.0/24 range, and this is in VLAN 300, and this is another VLAN F0/7 and F0/8. This is how the network 40.0.0.0/24 and VLAN 400. And the homework is that make sure the VLANs 100 to 100, 200 to 200, 300 to 300 and 400 to 400 communicate to each other. Okay, so these machines should communicate each other, these two should communicate each other, these two and these two, they should communicate each other, and they should not communicate to anybody else as well. Got it? You can do it, right? Okay, yes. So any doubts or any clarifications or anything you need? Arthik? Okay. Online guys, everyone fine?
Yes, sir.
When flooding happens, say if there is a flooding, will it go to other VLANs or it will be within the VLAN if we configure it like this?
Flooding happens only, that will be within the VLAN only. It will not go to another VLAN.
Okay.
Okay, yes. Anything else? Okay. So then, shall we wind up for today? Okay. So let me stop recording.